Hello, let us look at the rate question here uh, from AP Calculus free response section. The rate at which the people enters the auditorium, and notice here that R of t, that's the rate. Now, that's why you see the people per hour. Whenever you use the word per, implies that it hasn't taken the derivative from number of people function. No one is in the auditorium at time t equals 0. That means that's the initial condition. When door opens, now the door closes, the doors close, and the concert begins at time t equals 2. Okay, so how many people are in the auditorium when concert begins? Now, then basically what we're looking for here is this. We are trying to look at the integral from 0 to 2 for the rate, which is R of t dt. Now, then basically what we're going to be doing is this here. For y function, we put 1380 x squared and then minus 675 x cubed. We just change that into x. I'm going to turn on that function here. And window will be 0 through 2. And I'm going to just go for zoom fit 0. Okay. So since I'm looking for the integral, I'm going to go for second trace, number 7 here. Lower limit was equal to 0. Upper limit was equal to 2. That will tell us how many people entered the concert. And you can see that it was 980 here. So the answer is 980 people. All right, now find the time when the rate at which people enters the auditorium, that's equal to R of t is maximum. Now, how do you find the maximum value of t? Now, in fact, there are a couple different ways of doing it. Since in this case, we see that maximum is right over here from that sketch. So, one thing which you can do is you can just sketch the function from 0 through 2 and then goes up, and then you can just highlight that that is the maximum, and then we can figure that out. So if I were to just finish it in that manner, then it would have been something like this. I'm looking for the maximum, which is 4. And left bound, since this is 0 through 2, so maybe I'm just going to code it as 0.5 is the minimum. And obviously this is 2. I'm going to make the maximum as maybe 1.9. Close to 2. So between these two, press enter. Maximum is equal to this one. That's one way for us to do it. Another way for us to do it, it would have been this. Part B. You see, when they're talking about maximum, we're talking about absolute maximum. So therefore, we have to find where r of t or r prime of t is equal to 0. Now, r prime of t is equal to 0 at this particular point. So, or I'm just going to use the derivative of this one. Once again, first method seems to be the easiest, but you can continue on the second path as well. So here, I'm going to use this is equal to, I'm going to find the horizontal slope. Two times 1380 and then x minus 3 times, by taking the derivative of this one, 675 times x squared. Now I'm going to sketch the last one from 0 to 2, and then I'm going to go for zoom fit once again. You can see that at this point, r of t would be equal to 0. How do you find that one? Second trace and then 0, which is intersection. So left bound would be, that would be good left bound. Right bound, I'm going to call it maybe 1.5. And that's what we end up with, 1.363. So t here is equal to 1.363. Then to find the absolute maximum, what we have to do is this. We have to make a small chart. This is t, and then this is r of t. Now 0 and then 2 is very important, because when we are looking for absolute maximum, we have to check the endpoints as well. So here we have 1.363. Now, we need to figure out the value of r. So I'm going to go back here, and I'm going to turn original function on, and then I'm going to turn off the derivative. So in this case, actually I have to stop it for now. Window was that one, and then I'm going to go for zoom fit once again. Alright, now then we're just going to get the values here. Value of 0 is equal to, of course, 0. How about 1.363? That was equal to this one. So here we get 0, and then this one was 854.527, and then when it was equal to 2, it was equal to 120 here. Since you notice that this is the maximum, that's another way for you to do it. Both ways would be fine. Now, part C, the total wait time for all people in the auditorium is found by adding the time each person waits. Now, so this function W, but the W prime is given in this way. Find W2 minus W1. Now, that basically means by fundamental theorem of calculus, is the same thing as integration between 1 to 2 of the W prime of t dt. Now, then using the calculator, our second y sub 2 is that 2 minus t2 minus x times y sub 1. Y sub 1 was the r of t in our case. So I'm going to turn this one off. I'm going to turn on the second one. And I'm going to zoom fit. And it graphs the function automatically, keeping the x values from 0 through 2. Now, in this case, I'm trying to integrate from 1 to 2. So here, integration number 7, lower limit was 1, upper limit was 2. So once you integrate this one, you will get 387.5. So that will be the total wait time. Now, part B, part D, on average, how long does a person wait for the concert to begin? Consider all people. So on average, talking about how much one person waits. So that means we're looking for part D. We have to calculate the total wait time from 0 through 2. but we gotta divide by total number of people, which we calculated to be 980. So that's basically what we have to do. Then I'm just gonna go back to this one. And number 7, lower limit would have been 0, upper limit would have been 2, and then we're gonna try to see what we end up getting. So as you can see, was equal to 760. Then what we're gonna be doing is this. 760 divided by 980. Oops. So that's basically what we end up getting. 0.776 hour is the average per person, average wait time per person. All right, so basically that's how we can do it. And I'll see you later. Bye-bye.